Next, I would like to address another metric. We call it F1. When we do classification, I guess you know there are several metrics like accuracy, precision, recall, and F1 score. So F1 score, actually there are two kind of F1 score. The first is just a common F1 score, and the other is F1 score beta. So this is the F1 score. The F1 score matrix attempts to combine precision and recall into a single value of comparison purpose. So it may be used to gain a more balanced view of the performance. So the key point is balance. Balance means I want to make the precision and recall balance. That's why they use the F1 score. One means the weight of precision and recall is 1. So when we have 2 multiplied by precision multiplied by recall, and it is divided by precision plus recall. So we want to make sure the balance between precision and recall. But there is another matrix F beta. Okay? So F1 matrix give equal weight to precision and recall. But we have F beta means it with the recall with a factor of beta. So in the formula, usually we have 2 multiplied by precision plus multiplied by recall, and we have 1 minus beta multiplied by precision, and this one we have beta. So if the beta has the higher weight, then we can say recall is higher than precision. Let's say if we have beta right here. So let's say if the beta is 0.6, then 1 minus beta, it is 0.4. And the 0.6, it will give more weight to the recall, and 1 minus beta, it will be the weight for the precision. So that's the meaning by the F beta. But it is difficult to determine the weight. If you do not know how to determine the weight, we usually just use the F1 score. We assume that precision and recall have the same importance. The other kind of matrix, we call it average precision. And the average precision, we have the average precision at n. N, yeah, it means another kind of items that we want to measure. So it is 1 divided by m, and we do the multiplication of pk. pk if k item was relevant. So we have this formula pk multiplied by the relevant k, where relevant k is just an indicator that says whether k item was relevant. So it is 1 or 0. If it is 0, then the pk will also be 0, because every value multiplied by 0, it will be 0. If it is relevant 1, then we will check what is the probability or what is the precision. Okay. So in this case, this is the precision. Now let's check how we can apply this one. We have average precision AP at N. So let's imagine we will recommend N3 products. So N, there are 3 products. So we want to look at the average precision of 3 products to a user who actually added a total of M. That is 3 products. Okay. Now let's see, we have 3 products. This is a list. Okay. And in the list, there is 0 and 1. The meaning by 0, comma 0, comma 1. It means there are 3 items that are recommended, and the last item was liked by the users. So 3 items has been recommended. Because this is 3 recommended items. Maybe if it is in the online store, we can see. When we search something, there are 3 recommended items or there are 5 recommended items. And among those 3 items, the item number 3 was liked by the users. So the other 2 is not. And we can measure like this one. The precision at K. The precision at K means we have the precision of item 1. What is the precision of item 1? It is 0. Because we recommend the item, but the user did not like it. What is the precision in the item 2? It's also 0. Because we recommend the item, but the user did not like it. What is the precision at the item 3? It is 1 divided by 3. It means among those 3 items, among the 3 items, one of them has been liked by the user. Then the average precision at K, it means we have 1 divided by M. M in this case, we have 3 products. M in this case, we have 3 products. Then it is 1 divided by 3 multiplied by the summation of the precision. Precision multiplied by whether it is relevant or not. Precision multiplied by the product is relevant or not. Precision multiplied by the product is relevant or not. Then it is 0 plus 0 plus 1 divided by 3. So it has the value 1 over 3 multiplied by 1 over 3. This result is 0.11. Now, let's suppose we have another examples. 0.1.1. Okay. It means that 3 items are recommended. Okay. Again, we have 3 items. And the last 2 items were liked by the users. So the item number 2 has been liked by the users, and the item number 3 also has been liked by the user. So in this case, the precision at K, the precision at the precise item, for the item number 1, it is 0. What about the item number 2? The item number 2 is 1 divided by 2. Why? Because when it is in the item number 2, we want to look at these two items. We have the recommendation of two items and one item has been liked by the user. So it means among the two items, the item one and the item two, one has been liked by the user. Next, we go to the item three. In the item three, it also has been liked by the user. Then among the three items, there are two items that has been liked. So we call this is the precision at K. And we want to look at the average precision at K. The average precision at K, again, we do the 1 divided by M. 1 divided by M. It equals to the summation of the pk multiplied by the relevant k. The pk means whether the item, what is the precision of that item, and if it is relevant, then it is multiplied by 1. If it is relevant, it is multiplied by 1. So the summation will be 1 divided by 3, because we have m equals to 3, multiplied by 1 divided by 2 plus 2 divided by 3. Okay. This is 1 divided by 2 plus 2 divided by 3. And we can get the value of the average precision is 0.38. Now we can take a look again on this example, 1, 1, and 1. 3 items are recommended and all items were liked by the users. So we can get the first item from one recommended item. The first item has been liked. Okay. For the second one, from the 2 recommended items, 2 items were liked. So in this item, in the third item, from 3 recommended items, 3 items were liked. Okay. Then we can measure 1 divided by 3. Okay. 1 divided by 3 means there are 3 products, m equals to 3, multiply by 1 divided by 1 plus 2 divided by 2, which is 1, plus 3 divided by 3, which is 1. Then the maximum is 1. So the precision is 1. We can say that among the recommended items were liked by the users. So the precision equals to 1. So there can be another variation. For example, this one. 1, 0, 0. What does it mean? Three items are recommended and the first item was liked by the user. Okay. So in this case, how can we measure the average precision? At the first item, from 1 recommended items, 1 item was liked. What about the second? Among 2 recommended items, 1 item was liked. What about this one? There are 3 recommended items, and among 3 recommended items, 1 item was liked. So we can get 1 divided by 3. Okay. And we will multiply with 1. This is the precision. whether it exists or not. Okay, it is relevant item. Plus 1 divided by 2. Is it relevant? Actually, it is not relevant because the user was not like, and it is multiplied by 0 plus 1 over 3. Also, this is not relevant. Then it is also multiplied by 0. At the end, we have only 1 divided by 3 multiplied by 1. So the result is 0.3333 something. What about this one? The first, there are 3 items are recommended, and the second item was liked by the user. In this case, there is 1 item that has been recommended, but the first item was not liked, and 0. The second one, among 2 items, 1 item was liked by the user. In the third item, among 3 items, 1 item was liked by the user. Then, and if we want to calculate the average precision, then it is 1 divided by 3 multiplied by 0. Okay, this is not relevant. So 0 multiplied by 0, it will be 0. And then the second one is 1 divided by 2. Okay, this is relevant because it has been liked by the user. And it is multiplied by 1 plus 1 over 3. The last item was not liked by the user. Then it is not relevant. 0. So we have 1 over 3 multiplied by 1 divided by 2. So the result is 0.16. Okay. The last one is the same with this one. Okay. So you can calculate. And let's say we want to see the mean average precision. We have the average precision, and now we want to have the mean average precision. So the previous example shows the average precision, which applies to a single data point, like a single user. So this is user 1, this is user 2, this is user 3, user 4, user 5, user 6. So among the 6 users, I want to know the mean average precision. Because the mean average precision at K. Okay. So K means there are 3 items. So what about the MAP at K? So all that remains to average the AP at K. It is the average precision at K matrix over all your users. So this is the average at K of particular users. We do the summation for all users and divided by the number of users. So as I mentioned to you, this is user 1, user 2, user 3, user 4, user 5, user 6. So there are 6 users. Then we can just do the summation. Summation by 0.11 plus 0.38 plus 1 plus 0.23, 0.28 plus 0.11 divided by 6 users. So we will get the mean average precision 0.368. Okay. So there might be one question about this one. Okay, in the exam, please try to review. Now we look at the other kind of matrix. We call this is the accuracy of rank. The accuracy of rank, or we call the rank matrix, it extends the precision and recall, and we want to check whether the position of correct items in a rank list into account. So let's say if I have for a user, for the user one, let's say item 237 and item 899 are actually good. So the user like those items. But yeah, when we do the recommended, we recommend item 345, we recommend 237, and we recommend 187. So let's say we recommend 3 items, then yeah, the 345, 237, and 187 that we recommend. So we call this is it, because when we recommend the product, one of them has been hit by the user, or one item is actually good according to that user. So relevant items are more useful when they appear earlier in the recommendation list. So if it is earlier, okay, that is better. But if you recommend 10 items and if it appears in the rank number 10, it is usually not that relevant. So particularly important in recommendation system as lower rank item may be overlooked by the user. So if let's say you want to watch movie, okay, the recommender system will recommend you 100 movies. So will you take a look on the 100 movies? Will you look at the movies from the 100? You just want maybe the movie in the number one, number two, number three. Yes. Yes. So that's the meaning. So the rank position matters. So we have the word rank score. Okay. The rank score means it extends the recall matrix to take the position of correct items in a ranked list into account. It is particularly important in recommender system as lower rank items may be overlooked by the user. And yeah, this is the word that I mentioned before. Rank score is defined as the ratio of the rank score of the correct items to best theoretical rank score achievable for the user. Okay, maybe it's difficult to understand this one. Let's look at this equation. The rank score, it means it is the division of the rank score at P at this P divided by the rank score max. The rank score P is this one. The rank score P is 2 exponent rank I minus 1 divided by alpha, and the rank score max is this one, 2 power or exponent, this is exponent, I minus 1 divided by alpha. So usually we call it, this is hit. Hit is the set of correctly recommended items, and rank, it returns the position, and T is the set of all items in the interest, and alpha is the ranking half-life. The ranking half-life means usually we just set 0.5. Yeah. It is an exponential reduction factor. So this is a matrix, okay, leaf index. This leaf index, we want to look at the length list that is divided by 10 equal deciles. If you know deciles, so we will take a look about deciles later. So using the leaf index, we want to look at the numbers at the 10 equal deciles where the linear reduction factor, we call it, this is the summation of the SI. SI, it means the it's, and we put the number, okay, this is the number, or this is the dimension of its. What is its? Its is the set of correctly recommended items, or we call it hits. So the number of hits. So if this index, we have the leaf index. If the hits or the number correctly items that has been hit is higher than 0, so we will calculate with this formula. 1 multiplied by S1. S1 means the item in the position decile 1 plus 0.9 multiplied by S2. S2 means the position in the decile 2, and so on. If the position in the decile 10, then it will give you a very low value or low weight. And then we will divide with the total summation of the deciles. Okay, so H is the set of correct hits. Okay, so let's see the concept of decile. Decile means that each of 10 equals group into which a population can be divided according to the distribution of values of particular variable. Maybe let's see with example. We have 20 numbers. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and okay, until 20. Now we need to make it into 10. The word decile means it is 10. So if we want to make 10, it means this is the first group, this is the second group, this is the third group, fourth, fifth, sixth, seventh, eighth, 9, 10. Okay, so we want to make 10 groups of data. So if we have 30 data, then it means each group will have, if we have 30 data, each group will have 3. If we have 40 data, then each group will have 4. Okay, so we want to make into 10. Now I want to find the value of the second decile. What is the second decile? Because we know that this is the first group, so this is the D1. And this is the second group. So we call this is the D2. This is the third group. So this is the D3. And so on. Okay. Find the value of second decile. Then the second decile is here. D2. The second decile falls between the score 16 and 18. Then finding the average of these two scores, 16 plus 18 divided by 2. So it is 17. So the value in the second decile is 17. Okay? The second decile is 17. There is 20% of the score below this value and 80% are above. We call it, this is 20% below 17. Yeah, below 17 is 20% from the data. And higher than 17 means the 80% of the data. That's meaning by the second decile. What about fourth decile? Fourth decile means 40% of scores below the value. Okay? And 60% of scores, it is above the value. So you can find what is the best value based on the T4 or the fourth decile and so on. Okay. And we have another matrix, that is normalized discounted cumulative gain. So this is the formula, discounted cumulative gain, DCG. We use the logarithmic reduction factor. So in this DCG, pos means the position up to which the relevant is accumulated. So this using the logarithmic reduction factor by looking at the relevant plus the sigma of relevant divided by the log base 2. And we can use this NDCG with IDCG, idealized discounted cumulative gain. Maybe it's good to see with the example rather than the formula. So the assumption that items are ordered by the decreasing relevance. And we have the normalized discounted cumulative gain or NDCG. It is normalized to the interval 0 until 1. Okay, let's take a look with example. Okay. So using the rank score, what is rank score? This is rank score. Okay. So we have this recommendation. So this is the recommendation to a user. So let's say, yeah, user 234. And we have the item number, let's say this is the rank 1, this is item 1, this is item 2, item 3, item 4. This is based on the rank. So in the rank means, yeah, the first, the item, the number one, the rank 1, we recommend. Number 2 means the item that we recommend in the and if you look at this one, hit. It means, okay, the user like this item. And the user like this item. Okay. This is the recommendation. And this is the actual value. The user like this one and this one. Now, what is the rank score? So the rank score means I want to see the rank score of the particular user. This is user 234. So there are 20 recommendation and hits on the 4th and 20. So let's assume the ranking half-life or the alpha is half. Half means it is 50% from the recommended items. We have 20 recommended items, so half of them is 10. Yeah, usually we make this assumption just half of the recommended items. So when we use the rank score for the user 2, 3, 4, we can just put the formula. Okay, 1 divided by 2 exponent 4 minus 1 plus 10. It means for it is the position that the product has been hit plus 1 divided by 2 power of 20 minus 1 divided by 10. So this is from the rank of the second product that has been hit. So the rank score of the user is 1.08. Now we need to look at the maximum. What is the maximum? The maximum means if the user find it means the maximum will be in the rank number 1 under, okay, because the user hit 2 items, the user hits number 4 and number 20. So it means I want to know, suppose those 2 items is in the rank number 1 and the second item is in the rank number 2. So what is the maximum value of the rank score? The maximum value is 1,93. Then the normalized rank score, or we call is the actual rank score, is from the rank score here 1.08. This is based on the value on the rank number 4 and number 20 divided by the maximum score, which is 1.93. So we can get the rank score is 0.56. What is it? If the rank score is high, or if the rank score is nearby maximum, or if the rank score is 1, then the position is in the number 1 and number 2. Okay. If the rank score equals to 1.93, then it means 1.93 divided by 1.93, then it equals 1. If it is 1, then it is 2. If the 2 products are in the number 1 and number 2. Okay. Because the rank is in number 4 and number 20, then it is lower than the maximum value. Okay. So we can use also the leaf index. What is the leaf index? The leaf index use the decile. What is the decile? We want to divide into 10 equal decile. Now, let's check. Where is this position and where is this position? If we select the decile, so it means this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And we want to know where is the position that the product is in. If it is in the first decile, so it is S1. If it is in the first decile, then we will multiply with 1. So the higher weight means the more important. If it is in the second decile, it will be multiplied by 0.9. If it is in the third decile, it will be multiplied with This is 0.9. It will be multiplied by 0.8. If it is in the fourth, it will be multiplied by 0.7. And so on until this one is in the decile number 9. It will be multiplied with 0.1. Okay. So this is based on the formula that we have. This one. Oh, sorry, S10. Okay. So this one is S10. S10 multiplied by 0.1. So you can do the summation. If it is in the S1, we'll multiply with 1. If it is in the S10, we multiply with 0.1. And then we will divide with the total S1. So we will check if the position H is available or not. So if H is higher than 0, then we will calculate it. So here, because the H is available in the decile 2, then 1 multiplied by 0.9. S2 multiplied by 0.9. And this available in the decile 10. In the decile 10, it is multiplied by 0.1. Then we have only 2 hits. Then we will divide with 2. So the lift index is 0.1. Okay. So what does it mean? If the value is high, the more closer those product is in the top rank. Okay. If the value is low, then the product is in the lower rank. So that's how we interpret the rank score and the lift index. Okay, let me stop here. Let's have a break. Okay, I will continue after the break.